Good evening, everyone. This is lecture number 4, and I think we are dealing with thermodynamics, right? In this lecture, we will try to wind up all types of questions and probably move on to other topics. Okay. So, tell me what was I think we were doing the sheet, right? In the last class.
Yes, sir.
Okay, we had done done some questions there, and let us now try to wind up this sheet as quickly as possible. And let me start with this question, which is a very simple one, and I hope you can do this. This is match the column type, and it's a simple question, so I think you should be able to do this. So here comes the question. I think this is question number 44 from your sheet. The temperature of an iron piece is increased from 20 to 70 degrees Celsius. What is the change in temperature on the Fahrenheit scale? You will be able to do this, yes or no? Then at what temperature degrees Celsius and Fahrenheit have the same value? You must remember this. Value. I guess you know this, right? Then the third question is 100 grams of ice at 0 degrees Celsius is converted to steam at 100 degrees Celsius. Find the total heat. The fourth question is on similar lines. So basically, this is from thermometry and calorimetry combined. Both of them combining here, and you just need to know the conversions of degree and Fahrenheit, which temperature is equivalent in both the scales. Then we have question number 4. A ball is dropped on a floor from a height of 5 meters. After collision, it rises to a height of 3 meters. Assuming that 50% of mechanical energy is lost, goes as thermal energy. Calculate the rise in temperature of the ball in degrees centigrade. Milli degree centigrade. I'll give you 2 minutes to do this. I think you should be able to do this in 2 minutes. This is a straightforward question. Let's not waste time on this. You must be knowing this formula. Yes or no? Degrees Celsius to Fahrenheit.
Yes, sir.
Okay. Then the second part of the question was what temperature is equivalent. Remember this. Minus 40 is the answer for this. How much heat is required to convert ice at 0 degree? So first you convert it into water, then water temperature increases. You know this, right?
Sir, your video stucking.
My video is stucking. Just give me time where. Is it okay now?
No, sir, stucking again.
Let's see if I. Is it okay now? Or still stuck?
Okay, sir.
It's okay now?
Yes, sir. Okay.
Okay. So the first 3 questions are straightforward. The fourth one is also straightforward. What is the loss in energy? It is mgh1 minus h2. 50% of that is converted into heat. So you multiply it by 50 by 100. That must be ms delta theta. From there, you will get the value of change in temperature. I hope you got the answer. Yes or no?
Yes, sir.
It was pretty straightforward. Let us move on to the next set of questions, and these are the questions which might be coming in the exam. Again, it's a comprehension type, so there are 2 or 3 questions which are linked. Example number 42 to 44. A body cools in a surrounding of constant temperature 30. Its heat capacity is 2 joule per calorie. Thermal capacity. Initial temperature of the body is 40 degrees Celsius. Assuming Newton's law of cooling is valid, the body cools down to 36 degrees Celsius in 10 minutes. In the next 10 minutes, will cool down from 36 degrees Celsius to how much? That is the first question. I hope you can get the answer for this one. Yes or no? So first give me this answer. I'll give you a minute to solve it. Well, that is the correct answer. 33.6, and it's a straightforward question. You just have to apply Newton's laws of cooling. You get the first equation. You have 1k. It is actually minus k. Then you get the second equation. You just divide the two equation and get the value of x. Yes or no?
Sir.
You can expect one question on Newton's law because it has not come since long. So you might see a question on Newton's law. Again, this is the question that I like. And I hope that you can get me the answer for this one. The second question in the same comprehension, the temperature of the body in degrees Celsius is denoted by theta, varies with time, is best denoted by which graph? You should be able to give me the answer for this one. Which graph is denoting it correctly? I know you know the answer for this one. Tell me the answer. Which graph? Remember, this is an exponential graph. Do you know this? d theta by dt is minus k times theta minus theta naught. You know this? Yes or no, beta?
Sir.
The only graph which matches this is graph number 4, and therefore that is your answer. Yes or no?
Yes, sir.
Okay, then comes the last one. If you can do this, that means your Newton laws of cooling is well covered. When the body temperature has reached 36 degrees Celsius, it is heated again so that it reaches 40 degrees Celsius in 10 minutes. Assume that the rate of loss of heat at 38 degrees is the average rate of loss for the given time. What is the total heat required from the heater by the body? How much heat it will require from the heater so that you can take the temperature from 36 to 40? And this is the type of question that might puzzle you in the examination hall. So here is your chance to do it now. I'll give you 2 minutes. How did you get 7.2 joules? The body is at 36 degrees Celsius and I have to take it to, let us say, 40 degrees Celsius. The heat capacity of the body is given as 2. The change in temperature is 4 degrees. So your answer should be 8 joules. We will require 8 joules. We will require 8 joules to take it from 36 to 40 degrees Celsius. Yes or no?
Yes, sir.
So the answer should be 8 joules. Yes or no? Yes or no?
Yes, sir.
But the answer is not 8. The answer is 16 joules. Now, how come this one? Now remember, do you understand this is the heat required to take it from 36 joules, from 36 degrees Celsius to 40 degrees Celsius, ms into delta theta? Do you understand this?
Yes, sir.
But at the same time, what is happening is it is also losing heat to the surroundings by the laws of radiation, by Newton's laws of cooling. Yes or no?
Yes, sir.
So if the heater has to bring it back to temperature 36 degrees Celsius, apart from giving it ms into delta theta, it must also give whatever amount of heat it has lost or it will lose when it goes from 36 to 36 to 40, or it will be same as 48 to 60 because it is given there, right? The average loss of heat is the heat at 38 degrees Celsius. Yes or no? It is given in the question. It is also losing heat while it is getting heated up because that is lost by the process of radiation. Do we understand this?
Yes, sir.
So we will have to calculate that much amount which it has lost. So what do? You take the average, you take the mean, and you calculate the value of K. Do we understand this?
Yes, sir.
Then from this value of K, you find out how much heat is lost by the body in 10 minutes. Do we understand this?
Yes, sir.
So 2 multiplied by half, multiplied by 8, multiplied by 10. The answer that you get is 8 joules. It will lose 8 joules more. So the total amount of heat that the heater has to give is 8 plus 8, 16 joules. Do we understand this?
Yes, sir.
Is it clear? What was the catch in this question? The catch in this question was you had to see that it requires two heat. Heat number one, which is for increasing its temperature using your specific heat. Heat number two, remember when it is getting heated up, at the same time it is also losing heat by Newton laws of cooling. So you have to calculate that amount as well. So add both the amounts. It is coming as 8 joules in both the cases. Your answer becomes 16 joules. 16 joules is the heat that is required by the heater to get it back from 36 degrees Celsius to 40 degrees Celsius. Any doubts on this?
Mm. Sir, how to is came?
Yes, beta?
M value how?
M
MS
value how?
yes, sir.
M mass.
किसका mass? माना
The
दिया ना
mass
sir.
is not given. M into S is specific thermal capacity. That is given as 2.
Okay, sir. Okay.
Do you know the meaning of thermal capacity?
Mm.
Mass into specific heat capacity is known as thermal capacity or heat capacity. Do we understand this, beta?
Yes, sir.
So M is not given, but M into S is given in all this equation. M into S is given. M into S is given. Do we understand this?
Yes, sir.
Shall we move on to the next question?
Yeah.
If you've done this question, then I'm sure that Newton laws of cooling, any question that comes, you should be able to deal with it. Okay?
Okay, sir.
Let us now move on to a more interesting problem, which is this one. At 20 degrees Celsius, a liquid is filled up to a height of 10 centimeters in a container of glass of length 20 centimeters and cross-sectional area 100 centimeters square. Scale is marked on the surface of the container, as you can see. This scale, wow, gives correct reading at 20 degrees Celsius. Gamma L, coefficient of expansion of liquid. Alpha G, linear coefficient expansion for glass. Do you know these terms? Yes or no?
Yes, sir.
Then the questions come. The first one is very simple. The original temperature was 20 degrees Celsius. What is the volume of liquid at 40 degrees Celsius? It's a straightforward question. First, let us do this. I'll give you 2 minutes to solve this. Okay, then let us see which is the correct option. And this book says 1001 centimeter cube. You just had to put the formula, beta. Do you understand this? V naught into 1 plus gamma L. What was V naught? 10 centimeter into 100 centimeter square, right? 1 plus gamma into delta theta. What mistake did you do? Change of temperature. You took it at 10. That is why you got 1000.5. Yes or no?
Sir.
See? Simple mistake and you land up with the wrong answer. So you understand this, right? The mistake? Yes or no? Understood the mistake?
Yes, sir.
Now don't make a mistake in this part, because this is the part where I was expecting that you might make a mistake. The actual height of liquid at 40 degrees Celsius. The volume, you know, that is the actual volume. What is the actual height of the liquid? This is where you might make a mistake. Be careful. Take your time. Solve this. If you can get this, you will not be troubled by any question of this nature. 2 minutes. Well, remember what is happening here. The vessel is also expanding. Yes or no? So you will have to look at the expansion in the area of the vessel. Yes or no? Alpha is given, you multiply it by 2, you will get the value of beta. Do you understand this? And then you get the actual cross section of the liquid, no, of the vessel at 40 degrees Celsius. Now, what will be the actual height of the liquid? This is the actual volume of the liquid at 40 degrees Celsius, 10,001 or 1001, divided by the new cross-sectional area. And this is what you got to divide. Now, to divide, you will have to use a bit of approximation. So this question was given for that. We'll have to use a bit of approximation. So 100.04 is written as 100 plus 0.01 raised to the power minus 1. Then you take 100 out, then you use binomial expansion, and you get the final answer like this: 10.006 centimeter. That is the actual height of the liquid. Any doubts on this?
No, sir. Understood.
Okay. Then one more. This is the actual height of the liquid. But will the scale read the same thing?
No, sir.
No, sir. That is the next question, sir. The scale will not read the same thing. So everything that we have learned about expansion, thermal expansion, and scales, and everything is coming in this one question. Beauty of this question, a beautiful one. It encompasses everything. So here is your chance to get me the correct answer this time. I'll give you 2 minutes. It's just based on a formula. If you know this formula, you should be able to do this. Thermodynamics is all about knowing more of the things. 10.004, and I must congratulate you. That is the correct one. I don't know whether you got it by the correct means, because the smile on your face tells me that you might not have. You might have played the guessing game. This is the formula that you must remember, and this is the formula that I wanted you to remind. This is how you must remember it. Okay? True value is scale reading to
Yes,
1
sir. Yes, sir.
plus alpha multiplied by delta theta. If you remember this formula, you should do good. This one formula will save you in really, really bad times. Okay?
Yes, sir.
Okay. Multiple choice. Which one? In Newton laws of cooling, d theta by dt is minus k times something. The constant of proportionality k is proportional to what? A, B, C, D. I'll give you a minute to win it. Remember, bacha, it's a multiple option correct, and that is what the problem is. Oh, that means you don't know how this formula is derived. Yes or no? No, yes.
No.
No. So this is the time that you know. This is how it is derived. You know Stephen's law. Energy lost per unit area per unit time. Yes or no?
Yes,
This
sir.
is your Stephen's law. Yes or no?
Yes, sir.
Now this dq by dt is ms d theta by dt. Yes or no?
Yes, sir.
So this is the original formula of ms d theta by dt. Now for small change in temperature, I can divide it and I can take theta naught cube outside. You know how it is done, right?
Yes, sir.
So this d theta by dt, the rate of cooling we call it, is directly proportional to E, is directly proportional to A, is inversely proportional to mass, and it is inversely proportional to S. Do we understand this?
Yes, sir.
So the options that are correct are, I think, A, C, and D. Okay, it's given wrongly in the sheet. Can correct it, but this is how it has to be done. Do we understand this?
Yes, sir.
Will you remember this?
Yes.
This is one thing that you should not forget. Then again, my favorite, which may not be yours, but it is mine, comes this one. Simple question on calorimetry, which has multiple options correct. 5 kg of steam at 100 degrees Celsius is mixed with 10 kg of ice at 0 degrees Celsius. What is the correct alternative? The first one is definitely wrong. There's no point of going about that. It cannot be 160 degrees Celsius. So you got one easy one. It should not have been like this, but I don't know why it is there. I think it should be more like 0 degree or something in between 0 and 100. Anyways, wrong option. So this is definitely wrong. This definitely goes away. But what about the other three? You know the problem with this question, right? The problem when you mix water and ice or water and steam and ice, you know the problem, right? You know the problem, yes or no? What is the problem? If you don't know the problem, you will not be able to solve this. Okay, that means you do not know the problem. If you do not know the problem, I'll let you find out the problem and I'll give you 2 minutes to think about it.
B, C, D.
B, C, and D are correct. The problem with this question was that the mixture could have any three types of temperature. What are the three types of temperature? The temperature could be 0 degrees Celsius.
69.
The temperature could be between 0 and 100, and the temperature could be 100. So basically, you just have to find out whether the entire ice can condense. To condense entire steam, you need 2700 calories of heat. Yes or no?
Yes, sir.
But the mass of the ice is very less. And if you convert this entire ice into water and you convert this entire water from 0 degrees Celsius to 100 degrees Celsius, the amount of heat required is only 1800.
Yes, sir. 1800.
Okay. So this heat is more. That means the entire heat, the entire steam will not condense. So what you will have is a mixture of steam and water. Yes or no?
Yes, sir.
So this much amount of heat is required to take entire ice to water at 100 degrees Celsius. So that much amount of heat is available. How much steam will condense? 10 by 3 kg will condense. The total mass of water will be 10 is outside plus 10 by 3, 13, 1 by 3. Whatever is left is your steam because mass cannot change. Do we understand this?
Yes, sir.
Or it has gone above our heads? Do we understand this, bacha?
Yes, sir. Yes, sir.
Well done, sir. If you could do this, that means we are true to your next question, and I don't know why, but I think that this type of question might just come this time around. I'll also show you the question today, which we did in the last class, last crash course, and the same question came. You check out the last year paper as well. Example number 23 comes. The temperature drop through a two furnace wall is 900 degrees Celsius. As you can see, 1000 is on one side and you have 100 degree on the other side. Each layer is of equal cross-section area. Which of the following action will result in lowering the temperature theta of the interface? You understand the interface? Interface is the Bishwala layer. Do you understand this? Yes,
Yes,
or
sir.
no?
Yes, sir.
So now you are given options. And again, it's my favorite question. So you understand, my favorite question has to be multiple choice. Which are the correct options? By increasing the thermal conductivity of the outer layer, by increasing the thermal conductivity of the inner layer, by increasing the thickness of the outer layer, by decreasing the thickness of the inner layer.
Sir, question option at a time.
You want me to show you the question?
Once questions.
Question is very simple. You have 1, 2, 3 inner layer, outer layer, and Bishwala layer. Inner layer is at 1000 degrees Celsius, and the outer layer is at 100 degrees Celsius. That's it.
Okay, sir.
And you have to decrease the temperature of the interface. That's it. I'll give you 2 minutes. Then I must congratulate you that you have at least given me one correct answer. Remember, the question which might look very difficult might be very easy. You understand the formula that we have used, whatever heat flows through the from first to second, the same heat flows from second to third. Yes or no?
Yes, sir.
So you just get the value of this one. Yes or no?
Yes, sir.
And then you get it in the formula like this. Simple maths. Now you know what is the answer, right? You have to increase the
Thermal conductivity
of the outer layer and the thickness of the
inner layer will increase.
inner layer. Do we understand this?
Yes, sir.
Remember, the reason why we are doing all these different types of questions is that, and I can assure you, and you can check it after your exam, that questions that have come are on similar lines. You might even get one or two same questions in your exam. Which one? I really don't know. Which of the following graphs show the correct variation in intensity of heat radiation by a black body at a fixed temperature? Different frequencies they have given. And different temperatures. So what frequency the radiation will be more? So basically you have to understand whose frequency is more. Basically you have to understand whose wavelength is more, and then you will get the answer. Yes or no?
Yeah, I've adjusted, sir. I'll try. Sir, BC.
B and C.
BC.
No, that is not.
A and C.
A and C are correct. Wayne's displacement law? Yes or no? Lambda is inversely proportional to T. That means frequency is directly proportional to T. Just apply that formula and you will get your answers. Yes or no?
Yes, sir.
Do you understand this, everyone?
Yes, sir. Yes, sir.
This was a simple question on Wayne's displacement
Displacement law.
law. And I have this one, so I can't get the entire question in one sheet. So I'll be using two sheets here, two screens basically. An irregular rod of same uniform material is shown is conducting heat at a steady state. The temperature gradient at various sections with various areas, how does the temperature gradient varies? So you have seen the two graphs, yes or no?
Yes, sir. Just
These
wait,
are the
sir.
first two graphs. Remember, the body is not of a regular shape. The cross-sectional area is varying and it is steady state. These are the other two. And I patiently wait for your answers. Which one? And the answer is
B.
B. A.
B.
B is correct. And remember this formula, you already know this formula. This is just an application of this formula. If area of cross section is uniform, which is the case in the normal case, your dt by dx is a straight line. Yes or no?
Yes, sir.
Temperature gradient is constant. If area varies, remember steady state, K does not vary. So this entire thing is a constant. So the rectangular hyperbola comes into the picture. Yes or no?
Yes, sir.
A really simple question and it tells us a really simple concept and we get a really wonderful answer. Yes or no?
Yes, sir.
Okay, great. Let me see what is the next question. And I have got a different one, so I'll go to that. We just use simple concepts, and remember, this is how questions are framed in a JEE. Let's see if you can deal with this one. A vessel containing 14 grams of hydrogen and 96 grams of oxygen at STP. Chemical reaction is induced. Oh, such around chemistry. By passing electric spark in the vessel till one of the gas is consumed. The temperature is brought back to its starting value of 270 Kelvin. What is the pressure in the vessel? Wow, wow, we are gaib going. We are vanishing one of the gases. Let's see who does this. This is one question where you have physics mixed with chemistry. Let's see how your both subjects are. That means your physics is strong or your chemistry.
Sir.
It's a chemical reaction that is happening here. Yes or no?
Yes, sir.
So what remains? 96 grams of oxygen will be totally consumed with 12 grams of hydrogen. Yes or no?
Yes, sir.
So what is left is hydrogen. Yes or no?
Yes, sir.
How many moles of hydrogen are left? Only one mole.
One more.
PV is equal to nRT. Yes or no?
Yes, sir.
V is constant. I have brought the
Yeah.
temperature back to its original value. R is constant. V is constant.
Yes.
That means P is directly proportional to
Proportional
mu. And you get the answer here. Originally, there were 10 moles of gas present. Now it is only 1 mole. And we have our answers. Yes or no?
Yes, sir.
So, do we understand how questions are framed?
Okay, sir.
Okay.
Yeah.
Yes, bacha. Then this one.
Yes.
This one will test whether you know another important concept in the same chapter. Example number 6. A fine steel wire of length 4 meter is rigidly fixed in a heavy brass frame, as shown in the figure. It is just tight at 20 degrees Celsius. What is the tensile stress developed in the steel wire? The entire system is heated to 120 degrees Celsius. Young's modulus is given. Wow, Young's modulus. I love Young's modulus. In the steel wire, they're asking. 2 minutes.
B option, sir.
That is correct option. B option is correct. If you got this, well done. You just have to apply that formula of stress developed in a wire. Young's modulus multiplied by strain, and strain is alpha into delta theta. Here there are 2 alphas, so alpha brass minus alpha steel. Yes or no?
Yes, sir.
If you could do this, congratulations, you have done one part correctly.
Okay, sir.
Then this one, sir. The simplest possible question with a graph. And here it comes. Figure shows the expansion of a 2 meter long metal rod with temperature. What is the volume expansion coefficient of the metal? Straightforward question. Remember, in JEE, it will never ask you question directly. Ask you in an indirect way. They'll give you something. You have to just see what is there and just do what is to be done. Yes or no? Do I have the answer for this one?
Wait, sir. Just wait, sir. Five into 10 to the power of. అరే ఆప్షన్ లేదురా నాకు 5 into 10 to the power of -5.
So much time? Any problem?
Sir, just wait, sir.
Yes.
వచ్చిందా? నోరే ఫార్ములా వేసుకున్నా చెప్పు. ఆల్ఫా ఈక్వల్ టు డెల్టా ఎల్ బై ఎల్ ఇంటూ డెల్టా టీ కదా సార్. 1.5 into 10 to the power of -5.
You got the answer?
Yes, sir. 1.5 into 10 to the power of -5.
They are giving you 3 alpha. So it is 1.5 into 10 to the power minus
-4. Yes.
Okay, a silly mistake. But remember, whenever you have got matching options, be very careful about your powers. Okay,
Yes, sir.
this one. A figure shows two thin rods, one made of aluminium, the other of steel. Each rod has the same length and the same initial temperature. They attach at one end to two separate immovable walls. Temperature of both the rods is increased by the same amount until the gap between the rod vanishes. Where do the rods meet when the gap vanishes? A simple one. It should be simple. Yes or no?
They are attached. Yes, sir. Wait, sir.
Where will the rods meet? A simple question.
D.
And the answer is
Uh,
it will
Aluminum
meet to
will
the right of the midpoint. Aluminium.
aluminum will expand more, na, sir.
Yeah, that is why aluminium will come here. Yes or no?
Then it is. Yes, sir.
Silly mistakes. Take a lot of, what should I say? I can only say that do not commit a silly mistake. That's it. I can't say
Okay, sir.
anything more. Yes or no?
Yes, sir. My mistake.
These silly mistakes cause a lot of pain and you just lose on straightforward answers. Yes or no?
Yes, sir.
So try not to make those mistakes. I am looking for a particular question. And
Okay,
once we
sir.
are done with that question, I think we can say bye bye to this sheet. So where is that question? Where is that question? And here comes that question. A hollow spherical ball of inner radius A and outer radius 2A is made up of a uniform metal material of constant thermal conductivity K. The temperature within the ball is maintained at 2 T naught and the outside of the ball is T naught. Find the rate at which heat flows out of the ball in steady state. Find the temperature at R is equal to 3A by 2, where R is the radial distance from the center of the shell. Assume steady state condition. This is just to check whether you know simple things in life. Okay, think let me help you out. There are two ways in which you can do this. The first way is if you can find the thermal resistance of this inner shell and the outer shell. If you don't know the thermal resistance of the inner and outer shell, you can simply do it this way. Thermal current or dq by dt is minus Ka into dt by dr. Do you know this? Dt by dx.
Uh,
Area of cross section, you take a sphere of radius r, dt by dr. From here you can find dt by dr. Yes or no?
yes, sir.
Then you can integrate this and you can get the value of t as a function of distance. Yes or no?
Yes. Okay, sir.
Then you put the values at r is equal to a, temperature is T naught, at r is equal to 2a, temperature is T naught. You will get the relation between the two temperatures. Yes or no?
Yes, sir.
Once you get the relation between two temperatures, you can find out the value of dq by dt, and as well as you can find out the temperature of the distance 3a by 2. Yes or no?
Yes, sir.
That is how it has to be done. Do we understand this?
Clear, sir.
Okay, just keep this in mind. Maybe this question comes. Speaking of which, let me start the next sheet with the question that we did in the last year crash course. And the exact same question came in JEE of 2021. I think the only change in the question was I had given this as V naught by 8, as you can see. And I think in JEE 2021, the question was V naught by 4, I think. That was the only difference between the two questions. I'll again go through this question and probably I try to find out the JEE paper and show you that exact question in the JEE advanced exam. A cylindrical container having two non-conducting walls is partitioned into two equal parts such that the volume of each part is V naught. I think we have done a similar question this year also. A movable non-conducting piston is kept between the two. Gas on the left side is slowly heated so that the gas on the right is compressed up to volume V naught by H. Find the temperature and pressure on both sides if the initial pressure and temperature were P naught and T naught. Also find the heat given by the heater to the gas. Number of moles in each part is N. I'll give you time. Meanwhile, I'll just search out for that paper and show you the exact question that came in JEE. And we did this question in the crash course. Well, just to show you the question that we did, this is the question that eventually came in JEE Advanced 2021, and that was the question that I have just given it to you. That was the question that I had given. The only difference was just the difference in the values, and the question was exactly same. Do we see this?
Yes,
So
sir.
it happens at times that with due knowledge, if you do a question, a similar question will come in the exam. Were you able to solve this one? This is the question that we did. That was the question that was given in JEE Advanced. Do you got this answer? I think we have done a similar question today. I mean yesterday. We don't know what is happening on the right hand side, but we don't know what's happening on the left hand side, but we know what is happening on the right hand side. Yes or no?
Yes, sir.
Adiabatic process. So you can calculate the final pressure and final temperature because final volume is known. Yes or no?
Yes, sir.
Then whatever remains is pretty simple. You can find out the volume of the left part, volume of the right part. Since you now know the volume of the left part, PV by T is constant, so you can get the final temperature. Once you get the final temperature, you can apply delta Q is delta U plus delta W, and you will get the answer. I told you that, in the question that we did from the sheet, delta Q was not asked. Yes or no?
Yes, sir.
I told you they could ask delta U Q as well. Delta U plus delta W. Do we understand this, bacha?
Yes, sir.
We have done a similar question.
सर एक क्वेश्चन शीट में है सर.
ये सेम क्वेश्चन ये दूसरी शीट है. This is a different sheet, but the question given in the sheet that we discussed last class was similar. The only thing
sir.
was, the only
Similar
thing
question.
was, yeah, they did not ask delta Q. That was the only difference. Okay,
Yes, sir.
got this?
Got it, sir.
This one. Then
Non-conducting.
I hope you can do this one. A non-conducting cylinder has volume 2V naught, which is partitioned by a fixed non-conducting wall in two equal parts. Partition is attached with a wall. Right side of the partition is a vacuum and the left side is filled with a gas having pressure P naught and T naught. If the wall is open, find the final pressure and temperature in the two parts. You have a minute to do it. Remember, whenever someone says there is vacuum on the other side, which process should come into your mind? Told you in the last class. Free expansion. Do we understand this? There is no external pressure, so work done is zero. Yes or no?
Yes, sir. Yes, sir.
Thermally insulated, so no heat given. Yes or no?
Yes, sir.
So no change in temperature. So the temperature remains constant. But the volume has become twice. It's an isothermal process. Yes or no?
Yes, sir.
Once you see the answer, it becomes a very simple question. Once you don't know the answer, then it becomes a pretty difficult one. I'll just show you these simple things. You know this?
Yes, sir.
Gamma for a mixture and
Mixture of non-rate.
okay. Just keep this in mind. Okay.
Yes, sir.
Then there is a question on the mixture, which I would like you to do. Last question for today. There are two vessels. Mixing wala question has not come for a long time in JEE. Same question might come in your exam. There are two vessels. Each of them contains 1 mole of a monatomic ideal gas. Initial volume of the gas in each vessel is something. Equal amount of heat is supplied to each vessel. In one of the vessels, the volume of the gas is doubled without changing its internal energy, whereas the volume of the gas is held constant in the second vessel. Wow. The vessels are now connected to allow free mixing of the gas. Find the final temperature and pressure of the combined system. Two minutes to do this. Okay. Let me help you out.
Oh, yes, sir.
Basically, what you got to apply is once the mixture is mixed, you can apply this formula U1 plus U2 is equal to total energy of the mixture. Yes or no? They are not going to mix. They are not going to react the gases, right? Or yes or no? So mu1 C1 T1 plus mu2 C2 T2 should be equal to total number of moles into CV into T. Yes or no?
Oh,
Both the gases are monatomic. Yes or no? You understand this step?
Yes, sir.
This is what you need to calculate. To know one of the bodies has not changed in temperature, the process is isothermal. You can find out the heat for that process. Yes or no?
Yes, sir.
For one of the gases, volume remains constant. So you know the change in internal energy will be equal to heat supplied. Both the heats are given as same. So you can now equate both the heats. You will get the change in temperature. Temperature of one of the gases is constant, but the temperature of the other gas has changed. So you can find the final temperature of the gas which has changed. One of the gases was at temperature 300. The other gas has now come at temperature which is changed 438.6. That must be equal to total number of moles into CV into T. CV is same for all the three gases. If one was monatomic, the other one was diatomic, then you will have to use the new CV of this mixture. Do you get my point?
Yes, sir.
But here both the gases are monatomic, so the CV will remain same. So this question can be made more different by having one as monatomic and the other as diatomic. But that does just only makes the calculation part tougher. You'll have to calculate CV again. You put the formula, you find the heat given in the first process, you find the heat given in the second process, equate the heat, you will get the change in temperature of the second gas or the first gas. You find out the final temperature of that gas, N1, C1, T1 plus N2, C2, T2, CV basically will be equal to N1 plus N2, CV into T. And from there you can calculate the temperature of the gas. Once you have the temperature of the gas, once you know the volume of the gas, once you know the number of moles of the gas, you can calculate the pressure of the system mu RT by volume. Yes or no? Do we understand this, bacha?
Yes, sir.
That is how this question was solved. With this, come and end to this particular session. We've discussed more problems on thermodynamics. We have discussed problems on calorimetry. We have discussed problem on heat transfer. And I think we have done enough number of problems. So I think
Sir,
we'll.
कल करंट इलेक्ट्रिसिटी स्टार्ट करेंगे सर.
What, beta?
करंट इलेक्ट्रिसिटी.
Okay. So the next class, that is tomorrow, we'll start with current electricity. And we'll try to wind it up as soon as possible.
Sir, we are not much confidence in waves, sir. Once more explain waves.
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 Waves or current electricity?
हाँ, कल करंट इलेक्ट्रिसिटी क्वेश्चंस करना सर, लेकिन वेव्स का टॉपिक अच्छा नहीं है सर, कॉन्फिडेंस नहीं है सर.
Okay, let us first complete current electricity and then probably we'll move on to waves. Don't worry. Okay. So
Yes,
we'll
sir.
start with current electricity in the next class. That is tomorrow. Be ready. I'll probably send you the sheet for that. and we'll do current electricity tomorrow. Okay, take
Okay,
care.
sir. Yes, sir.
Good
Bye.
night.